It has been more than 4 decades since Voyager 2 left Earth, and yet, against every expectation, this small spacecraft continues to send back whispers from the frontier of the unknown. What began as a mission to study the giant planets of our solar system has become something far greater. Voyager 2, now more than 20 billion kilometers away, has crossed into interstellar space, a realm beyond the Sun's protective bubble, where the winds of our star no longer dominate, and where the true ocean of the galaxy begins. But this story is not one of silence or emptiness. Instead, it is a story of confrontation. For as Voyager 2 ventured beyond the heliopause, that invisible threshold marking the end of the Sun's reach, it encountered something that should not exist. A force, a boundary, a barrier unlike anything predicted. Its sensors registered an unseen wall of pressure, an invisible frontier holding back the Sun's breath and resisting the vast forces flowing between the stars. It was not smooth. It was not calm. It was alive. And it has left scientists questioning what we truly know about the galaxy we inhabit. Voyager 2's journey to this edge of the Sun's dominion began in 1977, when it launched alongside its twin, Voyager 1. These probes were designed for the grand tour of the outer planets, a once-in-176 years alignment that allowed them to visit Jupiter, Saturn, Uranus, and Neptune with gravitational assists. Voyager 2 remains the only spacecraft in history to have visited both Uranus and Neptune, showing us worlds of strange blue methane skies, mysterious dark spots, and icy moons that may harbor oceans beneath their shells. After completing this grand odyssey, Voyager 2 kept traveling outward, slipping through the Kuiper belt and heading for the edge of interplanetary space. By 2018, more than 41 years after launch, the spacecraft reached the heliopause. Scientists had long debated what this moment would reveal. Some believed the crossing would be abrupt, with the solar wind vanishing into the thin gas between the stars. Others imagined it would be gradual, like moving from shallow seas into the deep. But Voyager 2's experience confounded them all. Its plasma instrument, which had fallen silent on Voyager 1 year earlier, was still operational, and it detected something startling, a dramatic and unexpected spike in pressure. The solar wind, the stream of charged particles flowing outward from the Sun, was being compressed, slowed, and deflected in a way no model had predicted. Voyager 2 had found a pressure wall, a mysterious frontier at the very edge of the solar system. This pressure wall is not a physical structure one could touch. It is a boundary of forces, a tangled mass of magnetic fields, high-energy particles, and turbulence. Imagine standing at the shore of an ocean, where waves crash into rocks and currents collide, creating whirlpools and surges of energy. That is what Voyager 2 encountered, not emptiness but a cosmic storm, invisible to human eyes yet undeniable in the probe's instruments. The readings were unlike anything seen before. The spacecraft recorded a doubling in plasma density, evidence that the interstellar medium outside the Sun's influence was far denser than anticipated. Magnetic fields twisted and shifted, suggesting that the boundary was not static but dynamic, flexing and rippling like a living skin. Even the flow of galactic cosmic rays, high-energy particles from distant supernovae, behaved strangely, dipping in intensity when they should have risen. Something about this wall was filtering them, blocking or redirecting their paths. This revelation stunned scientists. For decades, we imagined the heliopause as a simple bubble, inflated by the solar wind and gently pressed upon by the interstellar medium. Voyager 2 showed us that it is far more complex, not a neat, spherical shell, but an irregular frontier, constantly shifting under the weight of cosmic forces. Voyager 1's crossing in 2012 had hinted at this complexity, but Voyager 2 confirmed it, revealing that each probe experienced the edge differently. Voyager 1's transition was sharp, as if stepping over a cliff, while Voyager 2's was gradual and stormy, filled with turbulence. Why this difference? Perhaps because the heliopause itself is uneven, shaped by the Sun's motion through the galaxy. Our solar system is not stationary. It sails through the Milky Way at more than 828,000 km per hour, plowing through clouds of interstellar gas, magnetic fields, and dust. Just as a boat creates a wake in water, our solar system generates ripples in space, and the heliopause may bulge, collapse, or ripple depending on what it encounters. Voyager 2, entering through a different region than Voyager 1, found itself face to face with one of these distortions, the pressure wall. The implications stretch far beyond curiosity. If every star is wrapped in such a dynamic cocoon, then the conditions inside each stellar system depend not only on the star itself but on the shape and strength of its heliopause. These boundaries may act as shields, filtering cosmic radiation and protecting planets from destructive rays. For Earth, this invisible shield may be one reason life could thrive. In another system, with a weaker or more chaotic boundary, radiation might overwhelm any chance for biology to flourish. This means habitability is not just about distance from a star, or the presence of liquid water, but about galactic environment. Our Sun's protective bubble may be far more important than we realized, and Voyager 2 has given us the first direct evidence of how fragile and vital it truly is. Yet with every answer comes more mystery. What is the true nature of this pressure wall? Is it permanent or fleeting? Could it be shaped by ancient shockwaves from supernova explosions that ripple through the galaxy? Or could it be part of a larger, unseen structure, an interstellar current running through the Milky Way like a hidden river? Some researchers even speculate that the heliopause might interact with galactic magnetic fields in ways we barely understand, creating barriers or gateways that alter how radiation and energy move between stars. If so, then our galaxy is not an empty expanse of stars, but a labyrinth of invisible walls, currents, and fields. The idea that space is simply empty void has already been shattered. Voyager 2's discovery confirms that the cosmos is alive with motion, shaped by forces that reach across unimaginable distances. Perhaps the most humbling truth is that Voyager 2 was never built for this task. Its technology is ancient by today's standards, its memory smaller than the average digital photograph, its power dwindling year by year. Yet this fragile relic of the 1970s has traveled farther than any human creation except its twin and revealed secrets of the galaxy that no telescope could see. Its instruments, still faithfully measuring and transmitting, are humanity's first senses in interstellar space. And even now, it continues onward. Each year, it moves another 500 million kilometers deeper into the void. Each transmission it sends takes more than 18 hours to reach Earth. Eventually, its power will fade, and its voice will fall silent. But by then, it will have left us with something priceless. The knowledge that we are not isolated within the solar system, but part of a vast and restless galactic sea. Voyager 2's impossible encounter with the pressure wall is not an ending, but a beginning. It tells us that the universe is not static, but turbulent and alive. It reminds us that the galaxy is filled with unseen structures, shaping the destinies of stars and worlds. And it humbles us with the thought that the first true step into interstellar space was taken not by us, but by a tiny spacecraft, drifting alone in the dark, carrying with it the story of Earth. So as we await its next transmission, one question lingers. What lies beyond this pressure wall? What deeper mysteries are waiting in the vast ocean between the stars? The journey of Voyager 2 is a reminder that the universe is still filled with secrets, and that the answers may come not in grand bursts of revelation, but in the quiet, steady pulse of a spacecraft that refuses to die. If you enjoyed this exploration, make sure to subscribe to Waves Discovery for more deep dives into the mysteries of space. What do you think Voyager 2 has truly found at the edge of our solar system? Could this pressure wall be just the first hint of something much larger, something that shapes not only our world but the fate of countless others across the galaxy? Share your thoughts below, because the story of Voyager 2 is not finished, and its discoveries may redefine how we see our place in the cosmos.